Hello, everybody. My name is Edward Rose, and this week we will be talking about reflection and refraction of light. And basically, what that means is just reflection is if a light wave is traveling, where this blue initial light wave is traveling, it will hit, let's say, diamond. So, like a diamond surface, it will hit it, and then this line right here reflects a reflected light wave, where it's going to bounce off and reflect. And refracted means it's going to go through the material, except its wavelength is going to change when going through the material, and also the angle of which it approaches is also going to change, and it's going to be kind of redirected in a different direction, and then also at a different wavelength. But we're only kind of focusing on the direction it gets reflected. So basically, we have this initial wave, it gets reflected and refracted. And we know using this axis of reference, this dotted line right here, where that's going to kind of be our horizontal, which I referenced throughout this problem, and it's going to help organize kind of like the thoughts. So basically, we have that the initial wave is at an angle of 35 degrees below the horizontal, so represented by theta 1, and then it has an initial wavelength of 550 nanometers. We're not really going to worry about that. And then so a reflected wave is reflected at the same angle which it approaches, or which the initial wave was, except it's going to be reflected upwards. So it's this theta 2 angle is going to be 35 degrees above the horizontal. So it's just gonna go like that. Okay, and then so that shows that this single light wave splits off into the reflected light wave, and then also splits off into the refracted light wave, and that's going to be represented by theta 3, which is the angle at which it's refracted through the material. So to do this, we use Snell's law, which is n1 sine theta 1 is equal to n2 sine theta 3. So basically, just the theta 3 angle. And so how we're going to set this up is n1 is going to be the index of refraction, or it's basically it's a way that light travels through material, and at which its like speed and wavelength is changed accordingly. And so for diamond, this is going to be 2.417, and the index of refraction for air is equal to 1. So we have n1 is equal to 1, the sine of theta 1, or which the initial light wave to the horizontal, is equal to 2.417, the index of refraction for diamond, and then sine of this angle. So basically, just through simple algebra, we can determine that the angle is going to be 13.73 degrees approximately above the horizontal. So that's going to be the angle at which it's reflected. So we're going to have 35 degrees above the horizontal here, and 13.73 degrees above the horizontal over here. And that's going to be the directions this single light wave is going to travel after hitting this diamond material. Thank you for watching, and remember to leave a like.